to do first. So we're going to split this one up more cleanly into 2 segments, just that way we can have some sort of early beginner stuff and then also some a little more advanced stuff too. So the first thing that we're going to work on is we're going to go back and do a little bit more Boolean logic. So we'll just review a bit on the Boolean logic we already did before, and then look at how we can actually use that to control some like really basic robot functions. And then also talk a little bit more about basically if statements and how we can make decisions. And then the second half will be focused on arrays and clusters, but mostly arrays, with a sort of an application looking at how we take values from a sensor. Are there any questions before I start? Okay, so let us do the following. Okay, that's not working again today. All right, so we won't do that. Can someone remind us what the not function does? And I'll bring up the little palette here. So this guy. Anyone want to answer that one? You guys still hear me? You guys still hear me?
Yes.
Yeah. Okay, so what does the not function do?
The not function just like inverts anything that comes after it. So like if it's not true, then it defaults.
Okay, great. And how about the or?
It compares 2 values, and if one of them is true, then the output is true. At least one of them is true.
Mm-hmm. And then the and.
If both the values are true.
Okay, perfect. So what I want to sort of start with today is a little bit of a challenge. So let me see if I can, that is kind of important today, unfortunately. Let's see if I can get that back. So say you've got, what's a good example on this year's robot? So say we've got the hopper, the intake that we want to deploy with a button off of the joystick. Does anyone have any thoughts on how we might write the logic for being able to press the button and have the joystick, to have the intake deploy, and then press the button again and have the intake retract?
If it's not deployed, then deploy it. But if it is deployed, then retract it.
Okay, I like that. So we're going to need that part too. So here is, do you think of any challenges that might happen? So what about when the button's not pressed, what should happen?
Do nothing.
Okay. So what happens when the button is pressed?
It either deploys or retracts.
So
Depending on what state it is, it goes.
We do. We will need to know what state it is in, both, so we can make that decision. What defines the button being pressed? Like, what if I held the button down? What would happen?
It would just do it once, because a press would be pressing it and then releasing it.
Okay, perfect. So that's the key, is that the definition of pressing the button isn't just that the button is currently being held down, but that the button has been pressed and released. That way, it doesn't matter how long the driver holds down the button for, it always does the same behavior. and it does not look like my tablet is booting, unfortunately. So oh wait, maybe I spoke too soon. Okay. No, that still doesn't look like that's working. Okay. Okay, well, we'll not deal with that today. Okay, so how might we detect that the button has just been pressed and released? So we've got an old value, right? We've got like what the value was on the button, right? So the button can be either true or false, right? And you've got an old value that the button was, and then you've got the current value of the button. So if we're looking for the button to be pressed and released, what would be the current value?
The current would be false, and then the one right before would be true.
Correct.
Okay.
So, okay, so let me see if I think there's a way to draw on the screen here. Oh, there is. Oh, wow. Okay. So, thank you. All right. So if we have, green's a nice color. Okay. So the x-axis here is time, and the y-axis is the value of the button. So it can either be a 1, which is true, or it can be a 0, which is false. And so we've just decided is, so say we start out with the button not pressed. We're at, we can change the color. We're at 0, and then someone decides to press the button, go to 1, and someone decides to release the button, we go back down to 0. Does that make sense to everyone, the plot?
Yes.
Okay. So what Amelia just described was the case where the old value was true, so that'd be anywhere here, and the new value is false, which would be anywhere here. And the only time that both of those values are true, like the only instant in time, is right here. And what we call this is a falling edge trigger. So you've got two edges to this bump, right? You've got the edge that's from a false to a true, and that is called a rising edge trigger. And then you have the falling edge, which would be your true and then your false. So let me see if I can move this now. Oh, I can't. Oops. Fancy. Okay. So if this is falling edge trigger, what are the values going to be for a rising edge trigger?
False and then true.
Okay. All right. So we've got the Boolean palette here. Let's look at the rising edge trigger first. What do we need to design a trigger that was only going to be true when we first press that button? Alex? Any other takers?
Oh, wait, my mic wasn't on.
Okay, go ahead.
I said something, and then my dad was like, you need to turn your mic on.
Okay, go ahead.
Do you need, like, to see if like the not is the same as like the opposite or something?
We will. So what do you want me to put down first?
Like to make the trigger thing?
Mm-hmm.
You need to get the joystick or the button value.
Okay. So I'll make a control for the joystick value. Let's see. Let's use this OK button here. So we'll call it joystick for intake. Okay. What else?
Loop. While loop?
Do you need like a while loop or something?
We are going to need a while loop.
Constantly comparing it.
Mm-hmm. We are going to need that. So let me drag that down in place. I'm just going to, just for convenience, I'm going to make it run forever. So I'm going to create a false constant. So this loop will never stop until I hit the abort button. What else do we need in the while loop before we do anything else?
The comparison, right?
So before we even get to the comparison, what do we need just to make the while loop not go crazy?
Oh, the wait time thingy.
Yep, exactly. So let me just grab the wait, and we will wait for 100 milliseconds. That'll be fine. Okay. So now let's do the. Let me save this. We'll call this Boolean triggers. Okay. So what about the logic now?
You need to compare it to like its opposite, right? And see if are we going for the rising edge right now or the falling edge?
Let's do the rising edge.
So if don't you need like a feedback node or something? Maybe
Yep,
like the
yeah, we can do a feedback node. So let me grab that. So that's in the structures palette, and then down here to the arrow. Okay, I've got a feedback node.
You should initialize it at the beginning, right? Like with the first value that you have, or a false.
Yep. Yeah, we can do either a false or the first value. Let's do the first value. That's a little bit better practice usually. So we'll connect this up to the initial value in the feedback node, so it has something for that very first loop cycle. Okay. Now what?
Then you need to grab the value and compare it and see if they're the same. And if they're different, then you're done.
Okay, so if they are, how would I compare to see if they're the same? Well, so how would I compare to see if they're the same or different, or whichever one you want to do?
And?
Okay.
Because then if they're both true or they're both false, you could not them both, make them true.
Okay, so let's do that. So, so what do you want me to connect to this? You want me to connect the current value and then the value out of the feedback node?
Yeah.
Okay. And here I'll just also hook up the feedback node so we're recording the previous value. So all this wire is doing is storing the last value in the feedback node for the next loop cycle. Okay. So what is this going to do, Alex?
It's gonna initialize with whatever we started with. So hopefully it should be a false because the button won't be pressed. Mm-hmm. And then, or whatever it is, and then it'll remember the value it is and as the last one. Wait, one of them has to be knotted or something. Because if it's changing and we want them to both be the same, doesn't one of them have to be like knotted? So if we're using an and?
Yes. So if we're doing the rising edge trigger, which one should be knotted?
The feedback node one thingy.
Okay. So you can right click on the wire and go to Insert, Boolean palette, and drop in a knot pretty easily. Okay. And then I'll go ahead and create an indicator so that we can see what that looks like. So that is, what I'm going to call this is, we're not to the point where we're actually deploying the intake yet. This is just the part where it would be, we'll call it trigger to start deploying, or we'll call it trigger right now, because we aren't actually deploying the intake yet. So I've also increased the wait time here in the loop, just so we can sort of see stuff happen. So if we go ahead and, oops. Oh, that's, okay. So if we go ahead and run that, okay, so our trigger is false right now. I'm going to go ahead and press the OK button. And I'm going to, when I press the OK button, I'm going to hold the OK button.
Oops.
Okay. Well, okay, and then if I release, you guys see that?
It's a falling edge trigger.
Yep, it's a falling edge trigger. So what do we need to do to turn it into a rising edge trigger?
Shouldn't we move the knot to like the other one maybe?
Yep, we can do that. You can also right click on something that you've placed and say remove and rewire. Sometimes LabVIEW is able to do that for simple things. Other times it breaks everything. But for really simple stuff, it does that pretty well. Okay. So running again. That seems wrong. Hang on.
Your feedback loop?
Yeah, there's something actually weird here. Hang on one sec. So I think Alex was correct the first time.
Yay!
Let me see what's going on here. So what I'm doing right now is I'm going to put it back to the way that Alex had it. That was the one that we were trying to make in the first place. So the previous value was false, true, true, strange. Okay. Let's try that. So what I'm going to do is I'm going to probe these lines so we can sort of see what's going on. So right now we have a true on the low on the value from the previous loop. So that's that probe right there. And we've got a false on the button itself. That should be ready to go. If we press it. Oh, I'm sorry. This is so. The issue here is this button is not acting like a joystick button right now. So there are different kinds of buttons in LabVIEW, and they can mimic different types of physical switches in real life. So if we go down to the mechanical action, we are currently set latch when released. So the button that we dropped in is actually a falling edge trigger. What we want is just a dumb button that just only is true when you're pressing down on it. And I don't know why that's why that's not the default, but apparently it's not. So what we want is switch when pressed. Pretty sure. Let's try that and see if that works. There we go. Okay.
Yay!
So, yeah, so that works. So now this button is acting more like a button on a physical joystick, which is what I was expecting when we were doing this. So just be careful. Sometimes these buttons, sometimes the issue is like a button that you placed, which is kind of weird. The other thing that you'll run into is a number of these button types will not actually run on the robot. So I think only switch when pressed, switch when released, and switch until released work when they're running on the robot. These other three down the bottom, if they're anywhere in your robot code or your dashboard code, they will actually crash when you're trying to run on the robot. So just kind of keep that in mind. Okay, any questions on this part before we move on to how we would actually now make the intake deploy or retract?
No.
Okay. So we've got our trigger. So we've got how we want to switch the robot back and the intake back and forth. I'm just going to name this right now. This is a rising edge. This part is a rising edge trigger. Okay. So we've got this part and we're going to need it. But now we need to make the part that actually toggles the intake back and forth. So someone other than Alex, does anyone have any thoughts on how we would take the information from the rising edge trigger and use it to toggle the intake back and forth? So how about what kind of information do we need in order to make the intake go from a retracted to deployed and then deployed to retracted? What information do we need?
You need which state it's currently in.
Okay. How might we store that information?
You would store it like each time you press the button, but I don't know, like just like in a variable. I don't know.
Okay. You could store it in a variable. That would work. Probably a little bit cleaner way is to use another one of these feedback nodes. So just like we're storing the previous state, well, actually, I guess we don't really, yeah. So let's see. Yeah, we need to store what state it's currently in. So we do need basically to remember what it is. So here, let's do this. So let's make this one. We'll call this intake, and true will be the intake is deployed, and false will be the intake is retracted. So you're right, Amelia, we need to know what its previous state was. So just so that we can hook up the wires, I'm going to put a false constant here just so we can hook up the wires, and then we're going to have to disconnect that in a second, but or actually maybe we won't. Let's see here. So in order to remember the previous value, we're going to use a feedback node again. Let's say that we want to start the intake retracted, which is what we do on the robot this year. We'll start it in the false position. And right now, if we just look at this, with this variable, with this indicator being the intake's current state, what state is this intake going to stay in? Like, what's it going to do throughout the match if we do nothing?
It's gonna stay false.
Yep. So it's going to stay retracted. We're not going to change anything. Okay. So what do we want to do when we press the joystick button? What do you want to have happen?
Depending on if it's true or false, switch to the other state.
Okay. So let's see. How would we can put that in first. So how would we switch to the other, like what can we use to switch to the other state? Like do the opposite.
You would like, could you just like inject a true somewhere in or into the feedback node, or would that not work?
So what do you mean by inject? I think some people know that term and some people don't. So why don't you describe to me what you want to try?
You just like put a true constant into the feedback node, like as the next value.
Okay.
Maybe
Oh, go ahead, Alex.
Maybe we use like a select or something, and then if it's true, we inject a true, or like the false, like it sends in whatever it is that's its opposite.
Okay. So the select block is here in the comparison tab. Okay. So what should I be hooking up here?
You hook up the end thingy, like at the end, like the output into the feedback node, like as an inject.
Okay. So okay, don't worry about the broken wires. You can deal with broken wires later. What's next?
Then you take what the opposite is, and if you take like what it was before for the feedback.
Okay, so use a not. So should I use a not?
Wait, I'm still thinking.
Okay.
Would you like take what it was before and then put it in the question, but with like a not when or whenever you like get the rising edge true?
Okay, so let's start with that rising edge. Where should that go?
In the question mark one.
Okay. Okay, now what?
And then if it's true, you should put the feedback node, but with the not thing. So it's like whatever it isn't.
Let me delete that. So like this.
Yeah.
Okay. And then what's in the false?
Whatever the feedback node was before, like it just like continues.
Okay. Let's give that a shot. Okay, so I've pressed it. Our intake deployed. I'll release it. Intake is still deployed. And I'll press it again. Intake isn't deployed anymore. Press it again. Intake deployed. That seemed like what we wanted?
It actually worked.
It actually worked.
Yay!
Okay, so what we've built is we started with a rising edge trigger, and then we used the rising edge trigger to toggle the values back and forth. Are there any questions on that part right there? Okay, so there are more complicated ways to take the button inputs and control robot actions using the Boolean logic. And let's see, I don't want to go over those today. So today I'm going to put up another poll for more suggested topics, and that would be in the state controllers topic for how to do sort of more advanced comparisons between buttons in order to make different actions happen. But one thing that I will say is this right here is probably the most common coding question that I see come up on LabVIEW, on Chief Delphi. So a lot of inexperienced teams really struggle with how to, usually it's a piston, usually they want the piston to either go in or out, and they really struggle with how to convert their joystick buttons into making the pistons go in and out. So definitely if you're helping another team or anything, this is a good thing to know how to do, because this is almost always what they're struggling with when they just sort of have a pure code problem. Any other questions on this part before we go on to, I'm going to talk a little bit about case structures and basically if statements.
Wait, I have one question. What's the not doing again? Like that's true.
Yeah, so it's a good question. So if we're looking at the false first, this is, so if we don't have the trigger, this is do the same thing. Whereas if we're looking at the true portion of this, this would be do the opposite of what you were doing. So if the intake was retracted, then when you hit the trigger button, we're going to do the opposite. So we're going to deploy the intake. And then if we were to hit the button again, the intake's extended, so we're going to do the opposite. And now we're going to retract the intake. Does that make sense, Amelia?
Yes.
Awesome. Any other questions? Cool. Okay, so let me see if I can get rid of that drawing. Oops.
No, it's beautiful.
Too late. It's gone. Life is fleeting. Okay. So I'm going to open up a new sub-VI. Okay, and I'll save this one and call this case. Okie doke. So we've seen one way to choose between values before. So if we went to the comparison palette, we've been using, I'm now hallucinating, the comparison palette. We've been using the select block a lot. And so that allows us to make our choice and choose between two numbers. 42, great, and 65. I'll call it chosen. Right, so this is what we were using yesterday. Based on how we select that button, we can choose our value. And so the question arises, what do we want to do if we want to do something more complicated? So let's start with the following question. Say we want to choose, we have two buttons, and we want to choose between three different numbers. What do we have to do?
Compare them all.
Do what?
If we're choosing between the three numbers and two buttons, we have to compare them.
Okay, so what should I do here? Here, I'll make the second button. So I've got choose A, and I've got the second button, B. Okay, so what am I doing with these two buttons here?
I don't know. I was kind of just talking out loud.
Okay, that's all right. Anyone else have any thoughts? Okay, so what if we used two select blocks? So if we had two select blocks, and we hooked those up like this, spot 26. Okay. What do you think this is going to let us do?
Choose between the three numbers.
Okay, so let's see. So let's go ahead and run it. Make sure that this is going to work here. Yes. Oops. Okay, so if I click A, what should happen? What should our value be?
42.
Yep. What if I just click B?
65.
Okay. And what if I click A and B?
42.
42. Okay. Yep. So that is one way to choose between to sort of stack the select blocks together in order to be able to make more complicated choices. Think back to last year's robot, where we had, I think it was 14 different elevator set points. How messy do you think it would be to stack together enough select blocks in order to choose between 14 different states?
Fun.
Yeah, a lot of fun. I certainly would not volunteer to to write that particular piece of code. So fortunately, we've got plenty more options available to us. So if we go into the structures palette, we see case structures. And these are really, really powerful. You end up using these a lot. And I'll show you some of the features today, but they've actually got a lot of sort of hidden features that automatically configure themselves, which is pretty neat. So the way this works is you have two pieces. You've got the true case and you've got the false case. One of the ways that you can differentiate between them is if you right click on it and go to visible items and then go to subdiagram label, you can now type a comment here and you can have a different one in the false case. Okay. And just like with the select block, we can take one of our buttons and we can hook that up. And if we take the indicator, let's stick that over here. So they're forming, oops, that was kind of a bad example. Let me do the other thing first. So what we need to have is we need to have something inside of each one of these cases. So we'll take the 42 here. And if you click onto the edge of the case structure, onto the edge of the case structure, you'll form a tunnel. And that can be connected to the indicator. Right now, the tunnel has a white interior. That's because it knows that it's not wired on the other side of this. So we've got a broken arrow, and one of the things that's breaking that arrow right now, if I delete these things, we click the broken arrow, the error is tunnel is missing assignment to a tunnel. So it knows that right now, if you were to go into the false case, it doesn't know what to give it, right? It has no information on what it should choose. So you have two options. You can right click and say use default if unwired. What that's going to do is each data type that LabVIEW has, like whether it's an orange number or a blue number or a green Boolean, has a default value. For a floating point orange number, that's going to be 0. And so you can sort of see that you've got like a little bit of a slightly less closed tunnel. This will work. So if we were to run this right now, we can change between 0 and 42 by pressing this button. In most cases, I would strongly recommend that you do not use the default value. The reason that I say that is it can hide problems. So you'll see in a second that you can have more than 2 cases. So you can have 10 or 15 cases. And if you use the default value, sometimes you won't catch yourself when you forget to hook up something that actually mattered. And so my suggestion is that you always just put, they always just fully connect everything in each one of your cases. There are times when that can get really tedious, but you're less likely to screw up later if you change around your code. So we can make that 65. Now we can choose between 65 and 42. Are there any questions on using the case structure in this way? Okay. So we still have this problem of what if we want more choices? So what's one way using a case structure that we could choose between, we could choose one of 3 options?
Add a case.
Like on the outside or the inside or something?
I don't know, but it looks like you can add more. I've seen more.
You've seen more? Okay. So let me show this first, and then I'll show you where you've seen more. So you could sort of do really just the exact duplicate of what we did with the select box, where you could drop another case structure inside of here and hook up the B in there, and then just hook up a different number here. And this functions, you know, identically to how the stacked select blocks worked. But it has sort of a similar problem too, which is that, wow, this gets really, really inconvenient pretty fast. If you've got a whole bunch of cases that you want to do, nesting these is not necessarily the best idea. So the other thing that you can do is Boolean values can only be true or false. So you're only going to get 2 cases, two choices per Boolean value. But the case structures can actually be based on things other than Boolean values. So if we go back to the front panel and we create a numeric control, and we'll call this choose Z, because you could choose, and we'll call it choose infinity. You could choose whatever numbers you want. And teams, if I can spell it. One thing that we do need to do is, if we look right now, this choose infinity option is orange. It's a floating point number that can accept decimal points. In a later session, we can talk about why you should never use a floating point number to control a case structure. But for right now, know that basically sometimes the computer can screw up with floating point numbers and output the wrong value and basically do the comparison wrong. And so it's not robust for something that you're controlling a robot with. You don't want to use a floating point number. So we need to change this control to be an integer, so no decimals. So if we right click on this, we can then go to representation and click any of the integers. So any of the ones that say I. So we'll just pick I16, and we can go into more depth in another session as to what the differences are between all of the different integer types. But for this purpose, any of these would work fine. So now we're blue. And if we go ahead and hook up to the case structure, it automatically changes. So it automatically has gone blue here. And now instead of it being true or false, we now actually have case 0 and case 1. So we'll call it, we'll say this is 0 and this is 1. Let's go ahead and hook up. And we still have an unwired tunnel, so we'll go ahead and hook that up. Let's see if that, yeah, okay. So we're back to having two cases. So if we were to run this, right now we're at 65. If I were to type in 1, we go to 42. What do you think will happen if I type in a number bigger than 1?
Error.
It'll go to the default.
We'll go to the default, exactly. So if we type in a 4, we go to 65, and if you look carefully, 0 is the default. So when it has something that it doesn't recognize, it jumps to this case and we'll use this number. Any questions on that so far? Okay, so next thing. So now we want to be able to have more choices. So if you right click on the case structure, let me go to case 1 first here. Right click on the structure. Actually, let me do this. We'll do it wrong first so you can see. So if we right click on case 0, we can say add case after. And so now we have a case 2. We'll call this, we'll just make a note here. This is 2. This will work fine. There's nothing wrong with this. If I put in a 26 here, we can now choose between 65, 42, and 26. There is one sort of annoying thing though. If you click the drop down, you can see that it goes 0 to 1. This really has no impact at all on how the code executes. Everything's going to work perfectly fine. There's no problem with it. The only issue is when someone else goes to read your code, they may just click these arrows and not really pay attention to what number it actually says here. And they may just assume that it goes in order. So sort of the best practice is to now right click on the case structure and say rearrange cases. And you can just drag the cases to a different location. And so now if you click the drop down, you go 0, 1, 2. And there's really, again, that doesn't affect how the code runs, but it does make it a lot easier for other people to read your code. Generally, we don't like to make our manipulators or our drivers type in numbers in order to choose what elevator height they want to go to. So what we would talk about in the state controller session would be how to convert a whole bunch of these buttons, which is generally what drivers like to use, into a number that can be used to select the correct case. And so there'd be a conversion from a whole bunch of these buttons into a number to choose the case to make the robot actually drivable. We're almost at the end of the first hour. This is the last item on sort of the Boolean Logic section. Does anyone have any questions about this or anything else we've talked about so far? Okay, so what I'm going to do is I'm going to go ahead and switch over to looking at arrays and clusters. I suggest that everyone stay on. It's a little bit more advanced than what we've been doing, so I'll go a little bit faster on some of the basic stuff. But there's not really anything that I'm going to cover in it that you haven't that everyone hasn't already just seen if you've seen the first hour of this and the previous hour. So I definitely recommend that everyone still sort of stay on and watch the arrays, and then you can always go back and watch the recording later once you learn a little bit more and rewatch the array session. So let me do the fall. Okay. So does anyone want to talk about what an array is.
An array is like basically an item or like a variable that you can store like multiple values in.
Yep, that's absolutely correct. The way I like to look at arrays is they look like a lot like lists. So if you've got a shopping list, your shopping list is an array. So arrays are defined, so arrays are like lists. I want to be careful with that because different programming languages treat these very differently, like the actual word array and the actual word list. But for our purposes here today, you can think of an array as a list. And so, your array may have, say we're going to store numbers. So let me see if I can draw again. Draw. So if this is a box, or this is my shopping list, right? I can store all sorts of numbers in here. Color. Right, so I could put like a 5 in here, and a 6 here, and a 42, and a 14. Okay, so my list currently has 14, has 4 numbers in it. Let's see, 1 second.
Wait, I have a question.
Mm-hmm.
What's the difference between an array and a matrix?
Good question. So there are, I don't want to get like too ahead of myself with exactly the mathematical difference. In coding, people typically tend to use the words interchangeably. There could be some differences with how you multiply an array versus a matrix. There can be sort of some nuances of how you do math with the overall lists of numbers. So technically a list, an array, a matrix, and a tensor are 4 things that are sometimes used as synonyms. And a vector, sorry, 5 things that are sometimes used as synonyms, but do have subtle differences and do have differences between coding languages and between coding languages and linear algebra, like in math. So for our purposes, we're going to stick with using the name array, and we're going to treat arrays just as like lists of numbers. Is that okay for right now?
Yep.
Okay. We can go into more depth about exactly the differences later, but I want to at least start with just arrays that look like this. So if we've got this array, how might we, if we're the computer, how might we get a value out of the array, like a single value, or insert a single value into the array? So we need some sort of way to refer to each position in the array, right? The array basically has, in this case,
The index.
4 index. Yeah, exactly. So every number, every position in the array is defined by an index. Most programming languages, including LabVIEW, start with 0 as the first index number and then count up. There are a few programming languages that start with 1 at the beginning. They're weird. Generally people prefer to start with 0. And so what this is saying is that the number in slot number 2, or at index number 2, is 42. And the number at position 0 is 5. And so this allows us to ask the computer to give us, value number 3 from the array, or insert a new value into position 3 in the array. Does anyone have any questions about this idea of an index? Let me just write that here. So index. Well, that's an color. Okay, we'll just know that that's green. I can't change that apparently. Okay, so we'll set that off to the side here. And we'll look at how LabVIEW handles arrays. Oh, I just saw Lindsay's message in the chat. So yes, list of numbers, perfect. I will also say, Lindsay, that it can be a list of anything. At least in LabVIEW, you're allowed to make an array of pretty much anything. So it could be Booleans, it could be strings, it could be pretty much any type of variable. In other languages, there are more restrictions on what kinds of things can be fed into an array. But in LabVIEW, there's pretty much no restrictions. Okay, so we have an entire array palette. And the first thing I want to use is the build array block. And so if we drop that down here, excuse me, what we see is a single input and a single output. But if I hover over the build array function, I get a little arrow. I can drag it down and get a whole bunch of inputs and still only have one output. And so if I right click on each of these and type in some numbers here, I'm adding numbers to position 0, 1, 2, and 3 in the array. So Michael's asking, does this allow us to build a multi-dimensional array and not just a list? What he's referring to is that if we look at this, oh, now I can see Google Spaces. It was just hidden underneath the chat window. Yay, okay, cool. That's nice. So what Michael's referring to is that arrays can exist as in multiple dimensions. So we could also make an array where you've got 8 boxes. And so you could have some more numbers. So you could have 26, you could have 5, you could have 2, you could have 54, whatever. And you would also then have indices up here too, counting on the other dimension. And so you would need to, in order to get the value 65 out, you would have to say, okay, I'm going to go to index 1 and index 1 here. So the index, or let me give a better example. If I wanted to look at the 2, I'd go to index 2 on the first dimension and index number 1 on the second dimension to extract that value. Yes, LabVIEW absolutely allows you to make multi-dimensional arrays. And there are certainly good uses for that. Today, I'm probably going to stick with just single dimension arrays that are very much like lists. That's mostly what we use. For most things, that's enough. As you get to more and more dimensions, that's sort of where the naming convention for vector, array, matrix, tensor starts to come in, is how many dimensions they are and exactly how you want to name those things. Are there any questions on this? At least just the concept of having an array with multiple dimensions. Okay. I'll move that back down to the side again. Okay. So right now we've got just a single dimensional array with 4 numbers in it. I'm just going to right click and create an indicator so we can see what the values are. And one of the things that I want to point out is these orange lines that are going into it right now are thin compared to the orange line that's coming out of the build array. So LabVIEW use thicker lines to indicate that a value is an array versus a single number. And so if we find this and if we run this code, one of the things that's sort of weird is by default, LabVIEW doesn't show you everything. You have 2 options. You can click through the buttons to go from position 0, position 1, position 2 to position 3. If you go too far, it just sort of gives you like a grayed out value. Your other option is that you can drag down and see. And again, if you drag down too far, you'll get a grayed out value. And everyone, did that make sense to everyone? Okay, awesome. So let's look at some of the other array tools. And then what I want to show you is a demonstration of how to use the array in order to look at values from a sensor. So some of our other tools are, we can get the size of the array. If we just hook up the size there and create an indicator. So if we run this, what value should show up here in the array size? Alex is holding up a 4 fingers. I can now see the chat screen. Okay. Yep, exactly. Let's see, what other tools do we have here that I want to talk about? We can extract a specific value from an array. So we can hook up the array line. We can hook up an indicator. Let's see, element. We'll call it A for right now, and you'll see why in a second. And I'm going to hook up a control so we can change the index. So this is the index that we are going to use to extract the value that we want. Oh, it keeps hiding it up here. That's not very helpful. Okay. So if we run this with index 0, we're going to get a 42. If I were to type in index 3 and run it again, we'll get the 14, the value in the position 3. I'm not sure what LabVIEW does. If I type in a number larger than the array size, it'll return 0, at least for a floating point number. You'll want to check to see what my guess is it returns the default value for that data type. But you should always sort of check that. Again, you're going to want to be very careful. We can talk more about that in a little bit. Want to be very careful that you never put in an index that is outside of the actual size of the array. Okay. Next thing that we can do is, so still staying on the index. If you drag this one down, you can actually see you get a lot more ports. And by default, if you just have one index hooked up and you run this, oh my goodness. And when you hit run, you're going to get the value at index 2. Okay, and then you're also going to get here the value at index 3. So these count up. So this would be index 2, 3, 4, 5, 6, 7, 8. And so basically, it takes whatever the last one is that you put in and then counts up. You can override that. So if I were to right click on this and create, I'm just gonna make a constant because it's easier, a 1, we should get a 26 and a 42. Or I'm bad at math. 26 and a 1, so 1. So a 60, sorry, a 26 and a 65 because 65 is in position 1. The 0 would have given us the 42. So you can override these little guys. Generally, I try to write my code so that it works if I just do this, just because it can be super annoying to hook up a whole bunch of values to all of these if you're doing something large. Any questions on the index array function? Okay. Next thing that we can do is we could change a value, a specific value inside of an array. So we can take this insert into array function, and we're going to hook that up to this output array. I'm going to call that the edited array. I'm just going to use the same index control just because it's easy. And let's go ahead and insert the number 254. So right now our index is at 2. Move that over here. And so if we hit run, oh, it does that. Okay. So I haven't used this function in a little bit. So when we inserted a value at position 2, it actually shifted everything after position 2 down. So our array is actually now 5 elements long. And so if we had done this at position 3 or 4, if we can do that. Now we have the 254 at the bottom, but we still have 5 total elements instead of 4 total elements. There is also a function called a replace, and that would, and so instead of growing the entire list in order to accommodate the new number, we can swap out a number. So let's do that real quick. So we'll hook up everything the exact same. The other thing is in most languages with an array, an insert means replace. There's not usually a way to do both an insert and a replace into an array in most languages. LabVIEW is a lot more flexible with that. Hook up the same index value just because it's easy. And we'll also hook up the 254. But the difference is going to be, this one is the, oops. This one is replace. And this one is insert. So now if we run this, we won't be able to do it at position 4. We put in a 1 here. Now we still only have 4 elements, but we've replaced the 65 with a 254. Do that with the last position, replace the last position with 254. I'm not sure what happens if we put in a 4. Let's see. If we put in a 4, it won't work. So for the replace function, if there is no value to replace, it just doesn't change the array at all. Are there any questions about the difference between inserting a value into an array and replacing a value in an array? Awesome. Okay. One thing to note is that when we're running robot code, the replace is more likely to be used than the insert. And the reason I say that is, if you do an insert over and over and over and over again, your array starts to get really, really large. And that takes up more memory space on the RoboRio. And you could exceed how much memory you can actually store. And so it's generally for robot applications that we're going to do, you want to have an array that you know the length, and then the length of that array, you don't really want it to change while the robot's running. But there are situations where you're going to want to do an insert, but in most cases we're probably going to be playing with the replace option. There's some math that you can do on arrays easily. So you can calculate the minimum and the maximum values in the array. And you can see there's actually 4 outputs here. If you look at the help, the first orange one is the maximum value. The first blue one is the index that it found that maximum value. And the second orange value is the minimum value. And the last blue one is the index where it found the minimum value. So if we look at the maximum indicator, max value, indicator. So what should the maximum value be, and what should its index be? $65 and 1. Okay, let's find out. 65 and 1. Perfect. Okay. That was Michael or Juliana in the group chat. Okay. Let's see if there's anything else I want to go over here. Okay, let's see. Oops. I think probably that's the only one I want to talk. Those are the only ones I want to talk about today. There's more options. Most of them sort of deal with moving between different numbers of dimensions and changing the dimensions of the array. I don't know if we want to go ahead and get into that portion of things yet. So let's go ahead and move over to, actually, before I move on, are there any questions on just arrays in general? We're going to stay on arrays, but we're going to move on to using arrays. Okay. So, let's see. Moving average. Okay. So I went ahead and made a fun little thing last night. So what we've got right now is we have a plot with basically time on the x-axis, and then on the y-axis we have the signal from some sort of sensor. So this could be an IR rangefinder. This could be the encoder on the sort of modules. It could be any sort of sensor like that, any sort of analog sensor. And I can play with the sensor value here by changing the slider. And the sort of direct reading of the sensor value is the green line. So as soon as I change this, the green line does exactly what I'm doing. Now the pink line is sort of following the sensor value, but it is not exactly the same. Does anyone have any thoughts on the difference between the pink and the green line and why we might want the pink line instead of the green line? Oh, sorry, hang on. There's a question real quick from Juliana. So the question was about how it handles matrix multiplication. We'll talk about that one separately. We haven't had to do it in the last 2 years, so we can talk about that if that comes up, but we'll focus on the single dimensional arrays for right now. So going back to the plot here, does anyone have any thoughts on the difference between the pink line and the green line, and why we might want the pink line instead of the green line, or vice versa?
A moving average, like the title.
Yes, you could cheat and look at the title of the of the code. That's one option. So what does the moving average do, Alex?
It takes an average of, you set like a range and it takes the average of it, and you like, we did it for the what's it called? Thingy.
What's the technical term?
Yes, it was a thingy. It measured the PSI, pressure transducer. We did this for the pressure transducer.
Pressure transducer. Yep, you're right. We did do it for the pressure transducer. So what's the point of the moving average?
To control and like level out your values.
Okay. So what Alex is saying is sensors aren't perfect. In the real world, you'll never have a flat pink line like it is right now. In the real world, even if the true thing that you're measuring isn't changing, there's always going to be some noise on the signal. It's always going to be bouncing around a little bit like the green line. And you don't necessarily want your robot to respond to every single little bump. You only want it to respond to maybe larger changes or changes that you're sure are real. And so by applying a moving average, you can get rid of some of that noise and sort of stabilize how your robot behaves, interacts with its environment. Does that make sense to everyone? Okay. So what is the downside of the moving average?
It's slow.
Oh, so if I go up to 1 and then go all the way down to 0, does everyone see how the pink line kind of lags behind the green line? Does everyone see that? Okay. So this is a fundamental trade-off with filtering data signals. If you want to remove more noise, you have to look at a larger block of time in order to do that average. But that increases what we call the latency, the delay between a real signal changing and then the filtered signal changing. And so this is a very real problem. We have it right now with the targeting code on this year's robot. We filter the signal from the limelight in order to get rid of noise, but we try to get rid of more noise by increasing the amount of time it's filtering for. And it became really laggy. So when Adam would actually go into auto targeting mode, it would take a long time for it to sort of adjust to new changes and lock onto the target. And so we had to make an engineering choice about how much noise can we tolerate versus how much latency can we tolerate in the signal. Are there any questions on what we're trying to accomplish first before we go into trying to actually build the code that does this? Okay, awesome. 1 second. Okay, so let me stop this. And what's going to happen here is, let's see, I don't want to completely delete what I've already done. Let's see. I'm going to do the following. Okay. That way I can cheat and look back at what I've already done if I forget. I'm going to go ahead and delete this. Oops, not all of it. Delete that. And delete this. So right now, all we've got in this block of code here, sorry, I did this at a different screen resolution than what I'm sharing my screen at right now. That's why it's a little bit weirdly sized. We've got the raw sensor value, and then we've got the sensor control because I don't want to have to remake that one. And then we've also got the plot because I don't want to have to remake the pretty plot. So what might be the first step for doing this?
Do we need to create the indicator so we can get the sensor values?
I have that made. So we've got the same thing that we had before. We've got the sensor value here that we can change, and we've got the plot. So all of that is already in place.
Then we should make an array.
Okay, perfect. Should we make the array inside the loop or outside the loop?
Outside.
Okay. So where should I go to make the array?
The array folder.
Okay. Thank you, Alex. Where inside the array folder?
Where is it? Is it initialize array?
We can do that. So I think I actually forgot to show you that. So that'll be an excellent way to do that. So we were using the build array before, which was this one, but that could be kind of annoying if we want a pretty large array to fill in all those values. So let's do Alex's suggestion and use initialize array, which I forgot to show you guys. So this one has 2 inputs always. There's no, well, okay. There is dragging, but that is for multi-dimensional arrays. So for single dimension arrays, we've just got the 2 inputs. You've got the size of the dimension. And what this is going to correspond to is how many values we're going to average over. So right now, this loop is running at 100 milliseconds. So for every one element that we have in the array, we're going to be averaging over an extra 1/10 of a second. So how long do you think maybe we should average over?
100 milliseconds.
So that would be an array of 1, right? So the loop time right now is 100 milliseconds. So if we average for only 100 milliseconds, that's one loop cycle.
And 10, whatever 10 times was that? I must have missed a 0 somewhere.
Okay, so if we do 10, 10 elements, that is going to be 10 times 100 milliseconds, which could be 1,000 milliseconds or 1 second. So let's average the value over 1 second. That's a pretty good number. And then we need a value. So when we use the build array function, we can put whatever we want in each individual index. When we use the initialize array function, we have to pick a number. We can talk later about some more clever ways to do this. They're going to be very situation specific, but for the ease right now, we're just going to start with a value of 0. We're going to start out the array with everything being 0. Depending on the application, that may mean that you have to wait a certain number of loop cycles before you can use your array, or it may mean that what you really want to do is initialize it with like the initial value the sensor had. So there's a lot of options, but for right now, we'll just start with starting out the array with 0. And we can bring that array into the loop. Okay, so right now this array has all 0s in it. What do we need to do to this array in order to start using it for stuff?
Add values to it, or like right over the 0s.
Okay, right over the 0s of what?
Sensor values.
Sensor values, perfect. So let's use the replace subset. Well, okay. There's actually a number of options for how you could do this. what would happen if I replaced a subset? Like if I did a replace operation, what index would I use?
Whatever one you're on.
Whatever one I'm on. Okay. So let's see.
You need a counter for that one.
You do. Fortunately, the while loop comes with a counter, so you don't have to make one. We've already got that one, so that's the counter. We're actually going to, the way we're going right now, we're going to do it a different way than I did it, which is okay.
Aren't we going to need to do like a modulus function or something? Because if that counter goes up to like 500, we don't want that.
Exactly. So do you want to explain what the modulus is? Because I don't know that everyone on here does know what it is.
Isn't it where you divide something, like you take the remainder? That's what you get. You get the remainder.
Okay. So that the modulus function is found under the numeric palette, if I remember correctly, and it's called quotient and remainder in LabVIEW. I don't know if you search modulus, I don't know that it shows up. Yeah, I don't actually think that. Yeah, this is a little bit different. It actually does not show when you search modulus, so you do need to know that it is called quotient and remainder. Okay, so we'll take our loop iteration, we'll plug that into the thing that we're going to be dividing, the numerator for the division. What do we need to plug into the denominator?
$10?
10, okay.
Maybe not. I don't know.
Well, why do you think 10?
Well, if you look at what it's doing, it's like the big number minus y times then your like remainder thing. So maybe it's not 10. Maybe it shouldn't be. Maybe it is 10 actually. I don't know.
It is 10. I'll let you stop talking yourself out of the correct answer. So we'll go ahead and bring in the 10. Okay. And then you have the remainder at the top and the quotient at the bottom. We don't really need the quotient for anything. We're just going to use the remainder. Can someone other than Alex walk us through what the remainder is going to be if we went from, let's make this easy just for a second so it doesn't take us forever. Let's make this 3. Can someone walk us through what the quotient, what the remainder would be as we went from 0 to 7? Someone who's not Alex. So we've got Michael or Juliana responding here. So 0 to 7, and if we increase beyond 10, 1 again. Okay, so we're going to use 3 real quick just because it's a little bit faster than the 7. So if someone wants to answer that for 3, so Juliana is correct for the 7. There we go. Okay, so now Alex is now Mr. Shanfield. So I guess technically that counts somehow. So what Alex is saying is that if we go from 0, 1, 2, 3, 4, 5, 6, 6, 7. So this is the input. So this is like here. And then we did the same thing. Oh, sorry, not the same thing, but if we had to look at the output, the remainder, what would happen is we'll go 0, 1, 2, 3, 0. Hang on, there we go. Alex gave us a fixed one. 0, 1, 2, 0, 1, 2, and then 0 and a 1. Does anyone have any questions?
Luke, why does that say 012, 013, 01?
0, 1, 2, 0, 1, 2, 0, 1. Is that correct? Did I screw something up? Pretty good. Does anyone have any questions on how this quotient's working? Or sorry, how the remainder is working? Okay. So what's going to happen is we're basically going to cycle through. We're going to constantly change which index that we're replacing the value of. And Alex mentioned earlier that the value that we want to replace it with is the sensor value. We need the array that we're replacing the value for. What do we need to do with the output from this array? This new one that's had the value replaced inside of it. This time it can't be Harold or Alex. Okay, we've got from Michael and Juliana, we've got average values. So if we go to the math, the numeric tab, there's actually a function just for this. There is add array elements. So we don't even have to do anything crazy with that. And then to do the average, we also need to divide it by the number of elements, right? So we've got number of elements here from that 10. Does anyone see the potential issue here with this block right here right now? No, that's just a thumbs up, Alex. That's not what's the potential issue right here. Different types. Yep. Okay. So does anyone remember on how to change from an integer to a float? Yes, Alex, you're allowed to talk now.
Oh, okay. You go to the numeric thing, and it's at like the bottom, maybe.
This conversion thing here?
Conversion thing, yeah. And you convert it to the DBL.
Apparently I didn't hit insert, so I'll have to connect that manually. Yep, exactly. Now our little red indicator is gone. Okay. Let me shrink this so I can see this at the same time. Oh, perfect. Okay. And and then this value, this is, what is this value here? The running average. So Michael and Julian answered. So the running average, so let's go ahead and plug that into the plot. So we've got just the raw sensor value, which was that green line, and then now the pink line, on the plot, the pink line will be the running average. So let me make that, let me label that. Average, and then raw sensor value. Okay. Do you guys think that this is this all we need? Do you think that this is going to work? So Juliana's asking if we need to tune the number of loop cycles we need to average over. If this is a real application, we absolutely would need to tune the number of loop cycles. 10 is going to work just fine for us here. What else might be a problem? So how about we run it and see? So if we run it right now.
Do we have a timestamp in the while loop?
We do not have a timestamp. What would we need the timestamp for?
Never mind.
Okay. You are correct that we are missing something in the loop. So if I move this value right now, what's happening?
Oh, we need to multiply it back or something. Like,
So how about we look carefully at, let's do the following here. I'm going to slow the loop down so that we can watch the values change. Okay. And hopefully Zoom won't like freak out on us and not let us see it move. So what I'm going to do is create an indicator on the array so that we can see the values that we're actually averaging over. Oops. Oh, something's wrong.
you're running out of seconds.
Yeah, give me 1 second here. Yeah, we are running out of seconds. That's true. That shouldn't affect it. Sorry, I just need to plug it into here. Okay. So can everyone see what's happening right now?
Oh, we didn't save it. We just kind of let it be.
Yep, exactly. So every time we loop around, yes, we insert the value in the correct location, but we run into the small problem of we don't remember our previous insertions because every time we loop around, we just grab the value from that we inserted, that we brought in from the outside, right? So that's all zeros. And then this is always all zeros too. And so we're just resetting every time. So how might we fix that?
We need one of those feedback nodes or switchy things like in the loop, like
Yep,
in the background.
exactly. So we need either a feedback node or a shift register. Since we played with a feedback node earlier today, let's use a shift register instead. So you can actually convert a tunnel, which is what this is, into a shift register. So if you right click on it, you can say replace with shift register. And see now we've actually got them both on either side. And after we do the insertion, we can go over and put that into the shift register. And now if we run this, see all of a sudden it fills up. And then now those values get updated as needed on each loop cycle, and we still remember the old values. And so now we've got the same thing that we had before, right? Does anyone have any questions about this? Okay, awesome. Let me see, so we've got about 15 minutes left. Let me see what else we've got that we want to cover. I don't know that we'll get to clusters today, which is okay. The clusters thing is pretty short, maybe like 15 minutes, so we can add on to that at the beginning of another session if we need to. The two things that I want to talk about here today are what might be a potential problem with doing the modulus in order to decide where we're replacing the value. And my hint to you is that whether or not that's a problem depends on what kind of math we're doing here. Does anyone have any thoughts there? So we haven't gone through, one of the other sessions I want to suggest is a PID session. Some of you have already talked to you about doing the PID. What if we were to calculate the derivative, the slope? What if we were to try and find the slope here? Like we were trying to find the slope over a running block of time, what would happen? So if we look at the array here, while we're running it, at all times, we always have the 10 most recent values, which is exactly what we want for doing an average. What is a problem, potentially, is that those 10 most recent values are not necessarily in order. So these are no longer, this is the oldest value and this is the newest value. They're completely out of order. And so if you've got these points and they're out of order, when you try to calculate the slope or do some other math to it, that value is going to be wrong. Since all we're doing is adding them together, it doesn't matter that their order is incorrect. And so this works fine for doing the moving average, but I want to show you how I did my end, so that it would also basically maintain the order of the values, and so just making sure that we always have the 10 most recent. So in my code, let's see if I can find it here. What I'm basically doing is I bring in the array just like we did, exactly the same. I pull the array starting after index 1, starting at index 1. So I get rid of the value at index 0. And then I use the build array and insert the value from, insert the remainder of the array that's earlier, or sorry, later, and shift it back up to 0, and then put the new sensor value at the bottom of the array. And so let me see if I can run this here. 1,000. And let's see. Just here, I'm going to stop this so that you don't have to wait 10 seconds for it to run. I'm just going to do 4 seconds. Okay, so right now, if you look at these values here, it's kind of hard to see. We've all filled up. We filled up all those values. If I move this real quick, see how it sort of propagates from the bottom all the way back up to the top of the array? So that allows us to maintain the order of the points. And so we can do math operations that do care about the order with this method. Are there any questions on the differences between those two methods? Okay. So the other thing that I was hoping to get to tonight, but I'm not sure that we will, let's see if we can, is for loops. So right now we're running in, I'm going to go back to the code that you all wrote. Okay, so this is the one with the method that you guys chose. We've all been running with a while loop, which runs while a certain condition is true. In this case, that the button has not been pressed. The other option is to run with something called a for loop. And that runs for a certain amount of counts, a certain number of cycles. So in the very top here is where you would say how many times the loop should loop for. Now, the reality of the situation is you can turn any while loop into a for loop if you wanted to. And we actually tend to do that a lot because there's some nice features about while loops. Sometimes it's convenient to just use a while loop as a for loop. Right, and so sort of the way you convert it, right, is if you took this I here and stopped the loop here after after I got above 10, right? So we would run it for 10 cycles. However, there are some additional advantages to using a for loop in LabVIEW in particular in order to work with arrays. And so the place that we're doing this is we are doing this in the sensor fusion for the distance from the limelight and the odometry in order to work with those arrays. And I'll show that. I don't think I'll get to show that example today, but it will come up again when we do the session on the LiDAR sensor fusion. But so the advantages of the for loop are as follows. So actually, before we get to the advantages, let's talk about what I want to do with the for loop. So this is not a great use of a for loop, but it's a good example of how to use a for loop. What I want to do is say that I know that this is my IR rangefinder, and it's sitting on the front of my robot, and it shouldn't be able to measure negative distance. Like, I just know that if it gives me a negative value, that means that there's like a problem with the wiring or something. That value is not real. And so I'd like to go ahead and remove all of the negative values, or in this case, what we're going to do is set all the negative values to 0. So you say, okay, well, maybe it's like really close to the sensor, but it's at least not negative. Does that make sense as sort of a goal that we want to achieve? Okay. So there are lots of very good ways to do that. The way I'm going to show today is not necessarily the best, and by best I mean the most computationally efficient. So it takes a little bit longer for the computer to run, but it does demonstrate how we can use a for loop in sort of an easy-ish way. So what we want to do is use the for loop to search through all of the values in this array and remove any that are greater than or less than 0. Again, an easier approach might be to just check at this point here before you insert the value and not insert the value. That'd be faster and all those things. But I just want to demonstrate the for loop. So if we're going to go through the entire length of the array and check each one of the 10 elements of the array to see if it is 0 or not, what we can do is take our 10 value here and put that into the n on the for loop. And so this for loop is going to run 10 times. And the really cool thing about the for loops in LabVIEW is if you hook up an array to them, you get a special tunnel. So see how the tunnel has like not quite a filled-in square? So if you right-click on that, what you've done, so this is a normal tunnel, and then if you do what's called enable indexing, it is an index tunnel. And what this is going to do is it's going to automatically do this operation for you. So it's going to go to, if we're running this through the for loop on count number 0, it's automatically going to pull out element 0 from the array. And then this next loop cycle will pull out element 1, next loop cycle element 2. So it's going to automatically do this operation for you for the array. Okay. Oops. So what we want to do is check to see if this value is greater than or less than 0. I'm going to kind of move through this a little bit quickly so we can get done around 8. We're going to see a lot more of this when we look at the LiDAR sensor fusion. If we go to the comparison palette, which we haven't played a whole bunch with yet, we have our greater than, less than, greater than or equal signs. So if we want to check to see if a value is less than 0, we could use the less than block and plug that in, and then right click and say 0. And if you hover over the help, you can see that that is the value in the upper part, in the upper terminal, less than the lower terminal. If you want to save space, LabVIEW also has a convenient is it less than 0 option. And that just cleans up your code a little bit. So we're going to grab a select block again. And if we are less than 0, if we're greater than 0, we're just not going to do anything. We're going to pass through the same value that we had before. We're not going to change it in any way. Whereas if we are less than 0, we're going to bottom out at 0. We're not going to let it go below 0. Does that part of this make sense to everyone? Are there any questions? Okay. Now we can do the next great thing, which is if we connect this output, the output of the for loop, again, we have an auto-indexed funnel. So it's going to extract the correct value for us here, and then automatically build us the array again on the output. And so if we disconnect this line here, and we drag this over here, you can see that again, we have a thick orange line. And so the sort of nice part is that it's going to do all of these indexing and array building operations for us automatically. So if we run this now, the raw signal can go wherever we want, but the filtered signal can never go below 0. It's stuck. And again, there's a million ways to do this, but the nice thing about the for loop is that it does sort of do this indexing and array building for you. So I don't think I'm not going to get to clusters tonight. We'll probably do clusters at the beginning of the next session and just get those out of the way.